Howdy everyone. My name is Austin Hicks. I'm here in North Texas, and today we're going to be talking about the Helical Pier and the innovations that it represents for the civil infrastructure industry. The basic premise is it's a high integrity solution for low integrity environments. Right off the bat, we have to answer the question, what is a helical pier? Pictured here on the right for the more visually inclined, it's a giant screw. More technically speaking, it's a steel underpinning system used to shore and stabilize new and existing infrastructure. The application of this is in foundations of any kind of infrastructure projects. Now, what we want to get into in this presentation are the key components, the basic anatomy of the pier, what the performance criteria are for both its installation and fabrication, what the installation procedure actually looks like, the conditions that a helical pier would be applicable in, and some of the comparatives to traditional pier methods. So right at the top, we've got the key components. These can be broken down into three categories. You have the termination point, which is the bracket or cap located at the top of the pier. This is highly customizable and will be discussed between the manufacturer and the engineer of record specific to project parameters. You have the bearing elements, which are the helixes that distribute the load to the soil itself. This is the business portion of the pier. These are also highly customizable and can be configured in single flight, double flight, and triple flight configurations. The final portion of the helical itself is the shaft. This is the central steel pipe that actually transfers the load from the helixes to the structure that it's supporting. Up next, we have the performance and engineering criteria. Now, when talking about foundation piers in general, you're going to be looking at either axial load or lateral load. Predominantly speaking, you're going to be looking at axial load, which is your compression and your resistance to uplift. When discussing helical piers, this is going to be given in a factor of torque, and that's going to represent its load-bearing capacity. These things are verified against the pertinent specifications, which are listed right here. The first two have to do with the flighting. This is going to be specific to the content and grade of steel that's used and how it marries up to the shaft itself. The shaft is governed by ASTM A500. Again, quality of steel, grade of steel, wall thicknesses, all of that's going to be contained in there. And the final portion of this is going to be found in ICC, which is going to govern the installation process. Now, this is an extensive document, but the primary takeaway from it is this formula right here. T times K equals QAll, which QAll represents the total bearing capacity. Now, the T factor is going to be specific to the installer. They're going to have to include in their submittal documents the torsional capacity of the drive head that they will use, and then the PSI that they achieve during install. Those two factors are multiplied together to get your T factor. And then your K factor is a more empirical factor that comes from the size of the pier itself. So on the next slide, we're going to look at a 2 7/8 pipe that's being installed. This has a K factor of 9. If you were to hypothetically install this pier to 1500 PSI, you would end up with an ultimate capacity of 56.01 kips, or 56,000 pounds of bearing capacity. These bearing capacities are tested against parameters included in ASTM's D1143, D3689, and D3966, which is going to be compression, tension, and lateral loads respectively. Now that we've familiarized ourselves with the makeup of it, we have to go through the procedure. The first step is the most important one. This is the site assessment. The basic condition that you're trying to satisfy during this assessment is what are the existing site conditions. You have to evaluate this either with the geotechnical report or simply installing a test pier. That's going to help you determine your pier sizing and spacing. In some situations, these piers are being retrofitted to existing structures, in which case there will be some excavation required, although it's minimal. This was used to expose the footings so that you can actually retrofit the pier and attach it properly. The next step in the process, you have an installation crew on site at this point, and they're going to distribute the materials throughout the job site. They're going to couple the piers to the approved drive head, and the operator will engage the rotary hydraulics so that the pier begins advancing into the ground. Depending on the job minimum requirements, which is going to be inclusive of your torque or potentially a depth, You may have to add on additional segments, at which case the operator will decouple, the segment will be added, and they will continue the process of advancing the pier. Once this is done and adequate kips have been achieved on everything, it's time to modify the piers so that they can accommodate the bracket or cap attachment. And again, this is how this mates up to the structure that it's supporting. The second most important part of the process is going to be the recording of the PSI achieved during the time of installation. This can then be put into the equation that we looked at on the previous slide, and the final bearing capacity of all the piers can be reconciled and approved by the engineer of record. So now that we're experts in the fabrication and installation of helical piers, we need to know when they're going to be a viable option. And this can be summarized into three categories. First off, you have the low integrity soil conditions. These are going to be soils consisting of heavy clay, groundwater, or sand. These conditions make it either extremely expensive and time consuming to install traditional piers or impossible outright. You have the accessibility constraint. The job site footprint does not allow the size of equipment that is required to install traditional pier methods into the job site, or weather conditions have persisted on a job site and they just don't, they prohibit this equipment to physically get in there and do the work. The final criteria is going to be constraints on the schedule. While it may be a perfectly viable option to install traditional piers, there's just not enough time to do so. I've referenced traditional piers a couple times, but as a brief summary, you have two primary categories. You have straight shaft piers and you have bell-bottom piers. The predominant difference is in fatty clay situations, a bell-bottom pier is incorporated so as to resist uplift, because a straight shaft pier, when the force is applied unevenly, will actually punch through the foundation of the structure that it's supporting. Now, both of these scenarios work fine in high integrity situations, but there's one situation that seems to dictate the demeanor of every project, and that's when groundwater shows up. Here pictured is a cased job. Instead of having just one drill rig, you now have a pump truck and a crane on site. The end result being the same one hole that was just simply going to be punched and filled with concrete now requires all of this additional machinery to accomplish the same end result. Take a minute to appreciate the footprint of all of that equipment, and all of it is for one hole. So now let's look at the scoreboard. In all of these situations where a traditional pier goes up against a helical pier, you have the expressed benefits of a helical pier being that speed comes into play, the effect on the environment as a whole, it's not constrained by weather, and the cost, while initially more expensive, after the results of the project are complete, should result in a net savings. On this next slide, we have a couple examples of where helicals can be installed. You have on the left and the top left, you have a couple of pools. Obviously, a drill rig is not going to make it down into those environments. Below the pool picture is a helical pier being installed for foundation repair. This is in a restrictive environment that a drill rig absolutely could not get into. And then here, pictured on the right, is one of the most competitive advantages a helical pier has. You can actually detach the drive head from the machine and run out lengths of hydraulic hose so that the pier can be installed in environments where a machine physically can't go. So in conclusion, we've discussed the helical pier. We've discussed what it is, how it's made, how it's measured, how it's installed, when it's best utilized, and how it compares to traditional pier methods. The helical pier provides a very viable and time and cost-saving alternative to the cased pier, or in some instances a belled pier, for construction projects that are prohibitively restricted by the constraints that we discussed earlier.